Hello, my name is Leon Barron. I'm a cloud service architect with vCloud Air, and today we'll be discussing how to connect your data center to a vCloud Air virtual data center using an IPsec VPN. Now, on the agenda today, we'll go through a brief introduction to what vCloud Air is, and then we'll get stuck into the IPsec VPN section, where we'll give an overview of the technologies and terms that we'll be using, how IKE works to create these VPN tunnels, what additional features the vShield Edge gives us in vCloud Air, what configuration options we have when we're creating this IPsec VPN tunnel from vCloud Air. There's a VPN checklist that I find is quite handy to use when configuring the VPN and also to troubleshoot if you have any problems. And from then on, we'll be focusing on the demo. So we'll be looking at the topology that we'll be using in the demo, how to configure it, and then actually running through the demo itself. So firstly, what is vCloud Air? Well, vCloud Air is VMware's infrastructure as a service offering that's built upon the tried and tested vSphere software suite. One of the advantages that provides is that if you already have a vSphere environment on-premise, then moving a virtual machine from a vSphere environment to another vSphere environment should be relatively straightforward. Now, to get virtual machines up to vCloud Air, you can use that option. You can create them locally on your vSphere environment and then move them across, or indeed you can create them natively in vCloud Air itself. Once you've got virtual machines in your vCloud Air environment, you can leave them in that virtual data center as a kind of an isolated island from your on-premises data center, so no connection back. That may work for some, but in most cases, customers want to extend their data center and they want to connect their on-premises data center with the vCloud Air virtual data center. And then the most common way of connecting these data centers will be by using an IPsec VPN tunnel. So how exactly does IPsec VPN work? Well, in our diagram here, we've got an on-premise network on the left-hand side with the IP address scheme of 192.168.22.x/24, and that network is protected by a firewall with the IP address 192.168.22.1. Now on the right hand side we have a vCloud Air virtual data center with the network there being 192.168.11.x, and that is protected by a vShield Edge. Now the goal here is that we want the left hand network, the 22 network, to be able to talk to the right-hand network, the 11 network, securely. However, as you can see, there is the public internet in between those firewalls. So to overcome this, we create an IPsec tunnel between the two peer firewalls, and then when data is sent from the 22 network over to the 11 network, it goes through that IPsec tunnel that's securing the packets. So, as I say here in the overview, one of the things to remember is that these networks must be different. So the left-hand network must be different to the right-hand network. If those networks need to be the same, that's a different solution. It's called data center extension. But for this, we will focus on the IPsec VPN implementation. So an IPsec VPN is a secure tunnel that can connect one data center, be it physical or virtual, to another data center, again, be it physical or virtual. Now, as the name implies, IPsec VPN uses the Internet Protocol Security Protocol Suite for encrypting and securing the data traversing over that public medium, the public internet, between the two data centers. Now, IPsec VPN is a framework of open standards, and the thinking here is that if you want to peer to, say, a third-party firewall appliance, as long as that third-party firewall appliance supports the IPsec open standard, then we should be able to create this IPsec tunnel to it. So to understand how a VPN tunnel is built, we need to understand, at least generally, how the Internet Key Exchange, or how IKE, works. IKE is responsible for creating the security associations, or SAs, between two VPN peers, and also for creating the IPsec tunnel itself so the data can be securely passed over the public internet. Now, IKE uses UDP 500 or UDP 4500 when communicating between the peers UDP 4500 is when it needs to traverse a NAT, and that's something that we'll deal with later on. Now, IKE version 1, which is the version of IKE that we use in vShield Edge, it has 2 phases. Now, think of the phases as being separate tunnels, where phase 1 is concerned with the 2 peers, the 2 firewall appliances talking to each other. Now, in phase 1, we have a number of parameters that are used by the edge. We use main mode, meaning that we do not use aggressive mode. For encryption parameters, we use triple DES, AES-128 or AES-256, and they're configurable. We use SHA-1 for hashing. We use Diffie-Hellman group 2, and we use a pre-shared key, which is again configurable. Now, for phase 1, the security association lifetime, how long this tunnel is going to stay up for, is 8 hours. And we have no kilobyte rekeying, meaning that no matter how much data goes through that tunnel, it will only be re-established once the 8 hours is up. So IKE phase 1 is concerned about the 2 peer firewalls talking to each other, but that's not really what we're concerned about here in the grand scheme of things. What we want is the networks that are protected by those firewalls to be able to talk to each other. And that's where IKE phase 2, the actual IPsec tunnel itself, comes into play. Now, we need to have phase 1 before we get to phase 2, so we still need to make sure the firewall can talk to each other. But once we get that up, the phase 2 parameters are very similar to the phase 1 parameters. Again, we have the 3 encryption types. We've got triple DES, AES-128 and AES-256. Again, we're using SHA-1 for hashing, so we're not using MD5. We're using ESP tunnel mode, and ESP is what encapsulates the packets and secures them across the public medium, the public internet. And the alternative here will be AH, authentication header, but AH has a problem traversing NAT, so we'll use ESP instead. For phase 2, we're using perfect forward secrecy, and we're using Diffie-Hellman group 2 in conjunction with that. And the security association lifetime for phase 2 will be 1 hour. And again, there's no kilobyte rekeying. Now, the 2 points that I have at the bottom, the first one is that phase 1 and phase 2 need to match. Now, on the vShield Edge, that's enforced. You only have one place to choose your encryption algorithms. And once you choose that, then it's going to be applied on phase 1 and phase 2. Where this is important to remember is on your third-party firewalls, where they may allow you to use, for example, triple DES and SHA-1 for phase 1, and then to use AES-256 and MD5 for phase 2. If a vShield Edge is trying to peer with a firewall with that type of configuration, it will not work. They must be the same. Now, the VPN that we create with a vShield Edge is policy-based, it's not route-based. What that means is that when the packets are going through the firewall, they will be matched against a policy. So they'll match against the source and destination of the packet. So in our example where we had 192.168.22 on the local side, and we had 192.168.11.x on the remote side, when that packet hits the local firewall should look at its policy and see, does it have a policy that matches a packet being sourced from the 22 network, destined to the 11 network? If it does, then it should send it through the VPN tunnel. If it doesn't match that policy, then it routes it normally. The reason why this is important is that a lot of third-party firewalls will default to creating route-based VPN tunnels. And what we need here to peer to a vShield Edge is a policy-based. So what additional features does the vShield Edge provide? Well, it auto-plumbs the firewall to allow for the IKE phase 1 communication to happen. So that's over UDP 500 or 4500. It also supports NAT-T, and that's where the UDP 4500 comes into play. So to explain a little bit about how NAT-T, NAT traversal works, if you imagine the vShield Edge is trying to peer with, say, a third-party firewall that does not own its own public address. If it doesn't own its own public address, it must go out through a NAT to reach the public internet. So when the vShield Edge needs to peer with it, it has to traverse that NAT to finally terminate on that third-party firewall. It does that using NAT-T and it switches from UDP port 500 to UDP port 4500 to accomplish that. As discussed before, we have those three encryption algorithms, triple DES, AES 128 and AES 256. And we have AES NI support, which should boost the performance because AES NI will offload that AES encryption algorithm to the underlying physical CPU of the ESXi host that the vShield Edge is sitting upon. So the algorithm is not done in software, it's done in hardware and should greatly improve the performance. As discussed before, we use ESP tunnel mode as opposed to AH. And some of its characteristics is that it allows for confidentiality encryption, which is the main focus of ESP. It allows for NAT traversal, which AH does not allow for. It's connectionless, so there's no overhead like the TCP three-way handshake. And if packets need to be resent, that's left to the upper layer protocols within the encapsulation. It has data origin authentication, meaning that it will make sure that it's receiving the packets from the correct originator. It can protect against anti-replay attacks, meaning that if there is a man in the middle that's injecting packets into that VPN tunnel stream, it will be able to detect that and drop the packets. And currently we support 512 tunnels for a compact edge. When we go to create the IPsec VPN tunnel in vCloud Air, we'll be given three options on how to create that VPN. We can create the VPN to an edge in the same organization, we can create the VPN to an edge in a different organization, or we can create the VPN to a remote site. Now, the first two are really only beneficial when we're creating VPNs to other vCloud Director or vCloud Air instances. And the benefit that it gives is that it allows you to log into that vCloud Air, vCloud Director environment and select the networks and the edges that you wish to tunnel. So it's a kind of a point and click way of doing or creating that VPN tunnel. However, the third option, the VPN to a remote site, is probably the most common use case because not only does it allow you to create VPN tunnels to other edge gateways, it also allows you to create VPN tunnels to third-party firewalls. Now, doing this remote site option, you have to configure it manually as opposed to a wizard-based tutorial, but it's quite brief and we'll go through it in the demo as well. Here we see the IPsec demo topology that we'll be using. On the top right hand corner we've got one vCloud Air virtual data center. The network that we're going to be using in the VPN configuration there is the 192.168.11.x/24 network. On the top left hand side we have a separate vCloud Air virtual data center, and the network being protected there is the 192.168.22.x network. Now, both of those virtual data centers have edges that own their own public IP address. And it'll be good to show just how easy it is to configure VPN tunnels between edge gateways. And in fact, the top right-hand corner virtual data center is in the US, and the top left-hand corner virtual data center is in the UK. So there'll be a fair distance between the two of them. The bottom left-hand corner data center is actually a physical on-premise data center. And here we'll be peering with a third-party appliance, Cisco ASA. And the network that's protected there is the 192.168.10.x/24 network. Now, in the diagram you can see that the ASA doesn't actually own its own public address. Its external interface is a private address range. So for us to connect to it, we're going to have to traverse that NAT, that external NAT. So we will indeed be using NAT-T to accomplish this VPN tunnel. Now, when configuring IPsec VPN tunnels, I found it very beneficial to have a checklist so that if you can go through all of these points and check every one off, then the odds are that this tunnel will come up first time and work correctly. So the first thing that we need to be aware of is that the local and remote subnets are different and do not overlap. If you do need to have the same network across both sides, it's a different solution. It's called Datacentre extension. But for the IPsec VPN tunnel, they must be different and must not overlap. We want to have phase 1 and phase 2 with the same encryption parameters. By default, the vShield Edge will enforce this, but third-party products may allow you to have different encryption protocols for different phases. We needed to have the same encryption for both phase 1 and phase 2. We need to make sure that phase 1 and phase 2 configurations match between the vCloud Air vShield Edge and the third-party firewall appliance. If they don't match, the VPN tunnel will not come up. We use IKE version 1, we do not use IKE version 2. This can be important because some third-party firewall appliances may default to IKE version 2. If you try to create this tunnel over IKE version 2, the tunnel most likely won't come up, and if it does come up, it won't function correctly. We use SHA-1 for hashing, so we don't use MD5. We use ESP, not AH. We're using Diffie-Hellman Group 2 for phase 1. And for phase 2, we use PFS that uses Diffie-Hellman Group 2 as well. Make sure that both sides have the same pre-shared key. Make sure that the VPN tunnel that you're configuring on the third-party appliance is policy-based and it's not root-based. Make sure that the NAT-T and the NAT traversal settings are taken into account. And I'll show you what I mean by this when we're configuring the peer IDs and peer IPs with the vShield Edge configuration. And make sure the firewall rules are set up for the local and remote subnet. This is something that can be easily overlooked because by default, the vShield Edge will auto-plumb the rules to allow the two peer firewalls to talk to each other. But we're not overly concerned by that. We want the networks that are protected by those firewalls to talk to each other. And by default, most firewalls will block any of that traffic. And it's the same with the vShield Edge. By default, those networks will not be able to talk to each other until a firewall rule is put in place to allow that. When we're configuring this IPsec VPN, we'll log into vCloud Director, select the org VDC, select the Edge Gateway tab and right-click on it and select Edge Gateway Services. We will then go to the VPN tab and check what public IP address will be used when creating this IPsec VPN tunnel. We will then click Add and configure a new site-to-site VPN connection. Now, as you can see here, we would need to name the configuration, and then we would need to define the local and peer networks, and then the VPN connection settings. I would see that the top section, the local and peer networks, being the IKE phase 2 parameters, because IKE phase 2 is concerned with the protected networks and how they communicate with each other. And what we're actually doing here is we're defining the policy. We're saying that if traffic comes from this local network and is destined to this peer network, I want you to match this policy and send it down through the VPN. The VPN connection settings then is defining the local and remote firewalls. So that will be the IKE phase 1 configuration parameters. Now, it's always good to know what phases is doing what, and not just for a theoretical sense. When you're actually troubleshooting a VPN, if the VPN tunnel goes down, it's much better to be able to say, well, this looks like it's a phase 2 problem or a phase 1 problem, and then just troubleshoot that section of the configuration rather than having to troubleshoot the entire VPN tunnel. So next we'll go through exactly what these parameters mean and what we need to fill out in them. So we first need to give this new site-to-site VPN tunnel a name and a description, which is fairly self-explanatory. We then need to choose the local networks that are going to be part of this VPN tunnel. And we do this by simply selecting the networks that are attached to the vShield Edge. We then need to define the peer networks. And by this we mean that the peer networks to the vShield Edge's perspective will be the local networks that you have on-premise. When we're defining them, we want to define them as a full network, not as /32 or individual IP addresses. If you need to restrict access to only certain virtual machines through this VPN, then you can do that using the firewall rules. Now, the local ID for the vShield Edge is going to be the public IP address that it's using for the VPN tunnel. What's more important is the peer ID and the peer IP. Now, the peer ID is going to be the local address that the peer firewall owns. So if that firewall owns its own public address, then the peer ID will be its public address. If, however, it does not own a public address, then it will be whatever private address it owns. The peer IP will then be the public IP address that is associated with that peer firewall. So again, if it owns its own public address, the peer IP will be the public address. However, if it's being NATed, this is where the public IP address is set. So for a NATed third-party firewall that we're trying to peer against, the peer ID will be the private address that it owns, and the peer IP will be the NATed public IP address. This is very important because when the vShield Edge tries to peer with a third-party firewall that's behind a NAT, if we set both the peer ID and the peer IP to be the public IP address, what will happen is the vShield Edge will start the communication, hit that public address, and then the NAT will forward it on to the peer firewall, and the traffic will reach there. The firewall will accept that traffic, and then it will respond. However, when it responds, it doesn't necessarily need to be aware that it's being NATed, and it might not know about its public IP address. So when it identifies itself to the vShield Edge, it will identify itself as its private IP address. Now, if we haven't told the vShield Edge about this private IP address, and we've only given it the public IP addresses, the vShield Edge will not accept it and will drop the tunnel creation. So the peer ID and the peer IP are very important here, and we'll see how they work when we go through the demo. Now, the local endpoint will be the external interface that the vShield Edge will use to initiate the VPN tunnel over. The encryption protocols are, as we discussed before, the triple DES AES-128 and AES-256. And the shared key is something that's automatically generated for you. You can create it yourself, but it must be between 32 and 128 characters. And they must be alphanumeric, so we can't use any special characters such as exclamation points or commas. And once we've got the VPN created and configured, it will look something like this. So with the theory part of this presentation done, let's get into the demo and we'll create those VPN tunnels for real. So to recap the demo topology, on the top right hand corner we have the first vCloud Air virtual data center. And the network there that we're protecting is 192.168.11.x/24. On the top left-hand corner, we've got a second vCloud Air virtual data center. And the network that is being protected there is 192.168.22.x/24. Both networks are being protected by vShield Edges, and both vShield Edges have their own public IP addresses. So we won't be traversing any NATs. And because they're very similar devices, the configuration should be very straightforward. Now, in the bottom left-hand corner, we've got the physical on-premise data center. And the network that's being protected there is the 192.168.10.x/24. And what's protecting that network is a Cisco ASA. Now, that Cisco ASA does not own its own public address. It's being NATed. So when we're peering with that ASA, we will also have to take into account the NAT traversal that needs to happen. So if I switch over to my PuTTY manager, I have connections to all three VMs. So a virtual machine in Virtual Data Center 1, a virtual machine in Virtual Data Center 2, and a virtual machine on-premise. So if I run the ifconfig command on each one of these virtual machines, we will see that the top virtual machine in VDC1 has an IP address 192.168.11.11. The next virtual machine in Virtual Data Center 2 has the IP address 192.168.22.22. And the bottom virtual machine on-premise has the IP address 192.168.10.110. Now, if we ping a public IP address from each one of them, we can see that the first virtual machine has access out. We can see that the second virtual machine has access out. And we can see that the last virtual machine has access out as well. However, if we try to ping between, say, virtual machine in VDC1 to virtual machine in VDC2, 22.22, we can see that it does not have connection. And the same is for the reverse. So if I try to ping from the VDC2 VM to the VDC1 VM, we can see that there too we're losing packets. So that's what we're going to try to accomplish today. We're going to try to set up those VPN tunnels between those two virtual data centers first and get those ping packets working. So if I open up my web browser to VDC1, I've already logged into vCloud Director, so I will navigate to the vShield Edge. And once I'm there, I'll right-click on it and click Edge Gateway Services. In here, I will go to the VPN tab, and firstly, I will click on the Configure Public IPs. I'll take note of this public IP address because that's the public IP address that I'm going to be using to establish this IPsec VPN tunnel to the other vShield Edge. So I will click Add to add a new site-to-site connection. I'll give it a name, so I will call it 2VDC2. Now, I could use these top two configurations if I wanted to. I could try to connect to an edge gateway to another organization. But because it's not used that often, I will use a remote network for every configuration just so that we can compare configuring a VPN tunnel between a vShield Edge that does not have a NAT in front of it and a Cisco ASA that does have a NAT in front of it. So I'll choose a remote network. Now we must first configure the phase 2 parameters, so we will select this local network being the 192.168.11.x network. And the peer network that we're going to be configuring here will be on the virtual data center 2 side, which is 192.168.22.0/24. Now, the local endpoint is configured for you. It's the external interface. The local ID is that public IP address that we caught from the Configure Public IPs section in the VPN. Now, the peer ID is going to be the local ID or IP of the remote vShield Edge. So let's go to another browser and go to that vShield Edge. Right-click on it and click Edge Gateway Services. And once that's open, we'll go to the VPN. And in here, we'll choose Configure Public IPs. So this is the local IP address for the vShield Edge in VDC2. So we'll copy that and we'll paste that into our first configuration. Now, because the remote vShield Edge owns its own public IP address, the peer ID and the peer IP are going to be the same. They're both going to be that public IP address. We'll leave the encryption protocol as AES-256, and I'm going to use this pre-shared key in the configuration of the VPN tunnel. So we'll add the tunnel on the other end now while we still have that open. In this one, we will give it a name to VDC1. Again, I'm going to establish this VPN to a remote network. And in the local networks, I'm going to choose the 192.168.22.0 network. And the peer network will be the 192.168.11.0/24 network. Now, the local ID is going to be the public IP address of this particular vShield Edge. The peer ID is actually going to be the local IP address of the remote vShield Edge. So we'll copy that and paste that in here. Again, because there is no NAT involved here, the peer ID and the peer IP will be the exact same. We'll leave the encryption protocol as AES-256. And what we'll do is we will copy the pre-shared key from VDC1 and we will paste it into the vShield Edge in VDC2. Now, before we click OK on both of these, just bear in mind that we've only been allowed to select that AES-256 once. So you can see that whatever we choose here will be applied to both phase 1 and phase 2. We were also not given the option to configure hashing, so we couldn't configure SHA or MD5. We didn't have the option to configure Diffie-Hellman groups or perfect forward secrecies or to select between ESP and AH. So this is all done by default. We're going to use ESP. We're going to use SHA-1 for hashing. We're going to use Diffie-Hellman group 2 for phase 1. And we're going to use perfect forward secrecy with Diffie-Hellman group 2 for phase 2. So we'll click OK on both of these and click OK there too. Now, with those VPN tunnels configuring, we should be able to go back to our PuTTY manager and try the pings again. So I'll start the ping from VDC1 VM. So I will ping 192.168.22.22. And you can see now we're getting a response. If I do the same from the VDC2 VM, I should also get a response. And I do. So you can see how easy it is to configure a VPN tunnel between two vShield edges. They're similar appliances and they will be able to speak to each other quite easily. There's no NAT involved, so it's very straightforward. So we'll now go on to creating a VPN tunnel to our on-premise ASA. I'll close the window for the VDC2 VM because we won't be using it anymore. And again, I will test communication between the VDC1 VM and the on-premise VM. And it should fail. And indeed it does fail. If I try the reverse from the on-premise VM to the VDC1 VM, that too fails. So we'll start the configuration by going into the vShield edge. I'll right click on the vShield edge and click Edge Gateway Services again, and we will go back to the VPN tab. Now we'll go to the Configure Public IPs to get the public IP address again and add a VPN tunnel. We will call this to ASA, and again we're going to establish this to a remote network. For the local networks, we'll choose our 192.168.11.0/24 network, and the peer network will be the 192.168.10.0/24 network. So far everything is the same. The local ID is the same. We use the public IP address that we have for the vShield Edge, and it's here that it gets a little bit different. So the peer ID and the peer IP. If we bring up our logical diagram again, we can see that the public IP address that this ASA is using is the 146.247.40.242, and the private address is the 10.23.190.217. So the peer ID is going to be the IP address that is owned by the ASA. So that's the private IP address. So we'll plug that in. So the peer ID is 10.23.190.217. Now the peer IP is going to be the public address, the NAT address. So that's going to be the 146.247.40.242. For the encryption protocol, we'll leave as AES-256, and this is the shared key that we're going to be using when configuring the ASA. So with that, let's open up the ASDM that's connected to the ASA. And firstly, I'll show you the interfaces. So on the ASA, you can see we've got two interfaces. We've got a transit and an external interface. The external interface is what we're going to be using to create this VPN tunnel on. And that transit interface is just an interface that links the ASA to the underlying networks, one of those networks being the 192.168.10.x. So very quickly, let's log into that ASA via PuTTY and make sure that we can actually communicate with the 192.168.10.x/24 network. Because if the ASA can't communicate with the network, then there's no way the VPN is going to work. So log in here. And once logged in, we'll go into enable mode and we'll try to ping the on-premise virtual machine. So that works. So that means that the ASA does have communication to that network. So we'll go back to the ASDM interface and we will go to the site-to-site VPN section. In here, we're going to add a new connection profile. So I'll click the add button. Now, even if we're not familiar with the ASA configuration, as long as we still understand how IKE and IPsec works and how the phases work together, we should still be able to work our way through this configuration. And that's what we're going to do now. So for the peer IP address, that's going to be the local IP address of the vShield Edge. So if we bring that up now and copy it, and we can paste that into the ASDM. The interface that we're going to be using to establish this VPN tunnel over will be the external interface. Now the IKE authentication. So we're going to use a pre-shared key. So let's go back again to the vShield Edge configuration and copy that pre-shared key. Paste it in here. Now, identity certificate, we're not using certificates to create this VPN tunnel, so we don't need to do anything with this. Now, the protected networks. Okay, so the local and remote network. This will be in the viewpoint of the ASA. So if we click on here, the local network to the ASA will be the 192.168.10 network. So I'll add that local network. And the remote network will be the 192.168.11 network. So I'll add that. Now I configured these objects already, but configuring the network objects is quite easy. So if you didn't have them there, you could just add them yourself. Now the encryption algorithms. So you can see here we've got an IKE proposal and an IPsec proposal. So you can see already that we could have two different proposals here. And we know that when connecting to a vShield Edge, we need to have them as the same. So let's click Manage on the IKE proposal. And it's giving us a few options, but let's create our own. So we'll click Add. We'll give it a priority of 1. Now the encryption that we used in vShield Edge was AES 256, so we'll select that. The hashing that we're using is SHA, so we'll select that. We are using a pre-shared key, and we're using Diffie-Hellman Group 2. Now the SA lifetime for phase 1 is 8 hours, so let's put that in. Click OK. And we'll select that as our IKE proposal. Now for the IPsec proposal, what the ASA is doing here is a kind of a fire and forget. It's going to use every single proposal that it has to try to establish this VPN. But instead, let's delete everything that's assigned and let's choose the one that we know is correct. So we need to have an IPsec proposal that's the same as the IKE proposal. So that would be AES 256 using ESP authentication and SHA for hashing. So it's this one. So we'll assign it and click OK. Now let's go into the crypto map entries in the advanced section. So it's asking us, are we using perfect forward secrecy? Yes, we are. So we'll enable that. What Diffie-Hellman group we're using? Well, we know we're using Diffie-Hellman group 2. Are we going to use NAT? Now, this is enabled here, and although it doesn't really matter, this is more for when the ASA needs to traverse a NAT, which we don't need to do when communicating with the vShield Edge. But we'll leave it on anyway, as it's not going to hurt anything. And the security association is going to be 1 hour, not 8 hours. The last part here is the IKE negotiation mode, and as we said, we use main mode, we don't use aggressive mode, so we will leave it as main mode. In the tunnel group, all that we have to configure here is to make sure the IPsec proposal is enabled. And we'll click OK. We'll enable it on the external interface and we'll apply that configuration. Now, as you can see there were some things that the ASA asked us that the vShield Edge did not ask us. But because we know what's going on in the back end of the vShield Edge and we know how it works, we were able to fill it out. So let's go back to the vShield Edge and click OK on that. Leave the vShield Edge configure, and then if we go back to our PuTTY sessions, what we'll do is I will debug the crypto entries on the ASA. So I'll type debug crypto ISACamp 255, and what that does is that once the ASA tries to create that tunnel, we will see a lot of output coming on here. Now the way the ASA and Cisco IOS create VPN tunnels is that once you place the configuration into them, they won't actually do anything until the first packet gets sent across. So you can see that nothing is happening on the ASA at the moment, and nothing will happen until I start sending traffic over that VPN tunnel. So that's what I'll do now. I'll ping from the on-premise virtual machine to the 192.168.11.11, my VDC1 virtual machine. And you can see here that it's failing. But you can also see that the ASA has not given me any output. So it's almost like it didn't try to create that VPN tunnel. So that traffic that I just sent there didn't mean anything to the ASA. So what could be the problem here? Well, a problem could be that we misconfigured the tunnels, but we know that we didn't because we checked both sides. The other problem could be that there's a firewall in place. Now, on the ASA, I've got the firewall pretty much wide open. So that's not going to be the problem. So let's take a look at the vShield Edge. So if we right click on the vShield Edge and click Edge Gateway Services and go to the Firewall tab, you can see that I've pre-created these firewall rules. So I've created a firewall rule to go to the VDC2 network and from the VDC2 network to come back, and a firewall rule to go from the on-prem network to the VDC1 network and the return traffic. So I had to create those. They weren't auto-plumbed like the IKE Phase 1 UDP 500 and UDP 4500 rules are plumbed. You don't see them here, but they are plumbed by default. So it's not the firewall and it's not the configuration, so it must be something else. And this is a very common issue with firewalls, with third-party firewalls, that if we go back to the PuTTY session, we'll see that if we try to ping out to a public IP address from the on-prem virtual machine, it can get out. Now that on-prem virtual machine has a private IP address, so for it to get out to a public IP address, it must be being NATed. And indeed it is. If I bring up the ASDM, go to the firewall section and the NAT rules, we can see that this management network is being translated to an external address. Now, why is that affecting our VPN tunnel? Well, what's happening is that the virtual machine sends traffic, it hits the internal interface and is immediately NATed. And after the NAT, the policy for the VPN is checked. But at that point, it's too late because the source of the traffic has now been changed to an external address. The destination is still the same, but when the ASA looks at its policy, it'll be looking for a packet sourced from 192.168.10.x going to 192.168.11.x, and it will not match it because the source has been NATed, it's been changed. So what we need to do here is to add a NAT exempt rule. Now, on my version of ASDM, there's a NAT exempt rule that I can put in there. I've seen other third-party appliances where you just NAT to the same address. So if your on-premise network is 192.168.10.x, you would NAT it to 192.168.10.x if the destination of that packet is the 192.168.11.x across the VPN tunnel. So here I'm going to add my source as being the management network, my destination as being the VCA network, and click OK and apply that change. And with that done, if I send another packet now from the on-prem network to the vCloud Air network, we should see a whole lot of output on the ASA. And indeed we do. And you can also see that we're getting replies back. So we now know that the VPN tunnel has come up, it's been established, and the networks can speak to each other. And as a final test, I can ping from the VDC1 virtual machine to the on-premise virtual machine. And indeed, that works as well. So that concludes the demo. It shows you how to create an IPsec VPN between two vShield Edges that own their own public IP addresses. And you can see how easy that is. And also, it shows how to create a VPN tunnel to a third-party appliance, and also by going through a NAT to get to that third-party appliance. As a footnote to this presentation, I already explained that when creating an IPsec VPN tunnel, we need to have different networks on the local and remote side. If you do need the same network on both sides, the solution is vCloud Air Datacentre extension. And as you can see here, we've got the 192.168.10.x/24 network on the left-hand side, and we want to stretch that network into vCloud Air. To do so, we must first deploy a vShield Edge and put one interface in that network that we wish to stretch, and an interface in any other network that is public-facing. Bear in mind that the vShield Edge that we're putting in there does not need to take over for the default gateway. It just needs to have an IP address in the network you want to stretch. With that, we need to deploy vCloud Connector Server and vCloud Connector Node on-prem. There's already a vCloud Connector Node deployed for you in vCloud Air. We register all the components, and the vCloud connector server will then create a layer 2 SSL VPN tunnel between your on-prem vShield Edge and the vCloud Air vShield Edge. Once that layer 2 tunnel has been created, the vCloud connector node will transfer the VM you wish to place in vCloud Air, and it will retain the same IP address information. So when virtual machines in the 192.168.10 network wish to speak to the VM that's over in vCloud Air with the IP address 192.168.10.11, they will operate as normal. They will ARP for the MAC address. It will go through the layer 2 SSL VPN tunnel, and communication will continue as normal. So that concludes the presentation, and hopefully the information provided here will help you when creating IPsec VPN tunnels to vCloud Air virtual data center environments.